The way users interact with technology is fundamentally shifting. With an expanding hardware ecosystem, digital experiences are moving beyond mobile screens, unlocking entirely new ways for your apps to blend into people's daily lives. Whether that's a glanceable experience on display glasses or a fully immersive one on a headset. But if you've never built for XR before, stepping into this can feel like a massive leap. How do you make sure your layouts translate correctly to entirely new form factors? Well, we have good news. The latest updates to tooling for Android XR are designed to make getting started seamless, even if you don't have XR hardware yet. So let's dive into how you can design and build XR experiences using your laptop today. We'll start with augmented experiences tailored for display glasses. If you've ever built a standard Android app, you already know the workflow. Inside Android Studio, you spin up a display glasses virtual device and select your system image just like any other AVD. Because these glasses rely on a companion phone, we've introduced a new pairing assistant to handle the heavy lifting. It automatically configures and pairs both emulators over a persistent virtual connection. Once they're linked, you're ready to launch your projected activity straight to the glasses. To see how this works, let's look at a prototype to-do list application. This project uses the Jetpack Projected library to manage hardware permissions and runtime access, alongside Jetpack Compose Glimmer to render a UI optimized specifically for glanceable experiences. The display glasses emulator supports touchpad gesture simulation, allowing you to test how your layout responds to physical swiping and tapping input. It routes voice input directly from your laptop's microphone, making it easy to test out real-time conversational capabilities, like using the Gemini Live API and function calling to append items to a list on the fly. Of course, building for optical see-through lenses means your UI has to complement real-world lighting. To help accelerate your development, you can preview your Jetpack Compose Glimmer UI directly in Android Studio, without needing to build and run your app on an emulator or physical device for small UI changes. Compose previews let you swap backgrounds between light, dark, or busy environments. This ensures your Glimmer UI components remain legible across different viewing and lighting environments. You can also test your Jetpack Compose Glimmer UI against different environments with our default environment options within the display glasses emulator. Additionally, if you want to test how your UI looks in a specific setting, you can use custom still photos as a static backdrop to ensure your UI remains legible regardless of the user's environment. And when something isn't aligning right, the Layout Inspector fully supports Jetpack Compose Glimmer components at runtime, letting you inspect and debug your app's UI by untangling nested view hierarchies and allowing you to inspect the attributes of the components and compare it to your design mockups. Now let's pivot to immersive experiences. Our tooling showcases how to implement spatial UI using the Jetpack XR SDK. By default, apps launch into what's called home space, which looks and acts like a traditional mobile window. But when your app transitions into full space, it takes complete focus. This unlocks custom 3D layouts, allowing you to leverage subspace composables like spatial panel, spatial row, and spatial column, while utilizing the Jetpack Scene Core library to display things like dynamic 3D models and custom virtual environments. Navigating this virtual world in your emulator is incredibly smooth. The emulator controls support both mouse mapping to pan, dolly, and rotate your perspective, as well as standard WASD keyboard navigation shortcuts to walk around and instantly reset your viewpoint. The emulator also supports pass-through. When enabled, pass-through mode displays a simulated indoor environment, which you can use to test your immersive experiences in mixed reality. And if you're configuring your app for wired XR glasses, remember, they rely on additive displays on semi-transparent lenses. To accurately test how your digital content appears against a bright background, the XR Glasses emulator features built-in dimming controls to adjust environment opacity levels dynamically. Whether you're exploring building glanceable, augmented experiences or immersive experiences, tooling for Android XR provides everything you need to start experimenting, prototyping, and refining your apps directly on your computer. The tools are ready when you are. Download the latest Android Studio Canary, spin up your first XR virtual device, and see where your code can go. Head over to developer.android.com/XR for full technical guides, documentation, and the sample apps we looked at today.